This video focuses on simplifying radicals. This first slide, don't need to write down the properties. What we have is a radical on the left, and we want to rewrite it. Notice the power can be written underneath or outside. And then the index is still out in front. The second property is two radicals that are multiplied together. In order to combine two radicals to multiply together, they must have the same index. In this case, the index is n. So what you do is you multiply the bases together, a and b. And now it becomes one radical. This next slide, again, you don't need to write the properties down if you don't want to. We have a radical divided by a radical. In order to combine them into one radical, they must have the same index. So in this case, they both have the same index of n, so you can combine it into one fraction with a radical, a over b. Property 4 is a radical. Notice this base has a power of 1. You can rewrite it as a fractional exponent as a raised to the 1 over n. Notice this is your index, is now a fractional exponent. The last property is a radical within a radical. What happens is, to combine it into one radical, you multiply the indexes together. So now you have m times n, and now it's one radical. Here are some possible factors that you will be removing in your radicals that you will need to memorize in this class. So there are perfect squares, like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc. And then there's some perfect cubes. 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, etc. Make sure you start to memorize some of these perfect squares and cubes if you haven't done so already. What we're going to focus now is just doing some quick simplifying of radicals. The first example is the square root of 9. The square root of 9 can be rewritten as 3 squared. It doesn't show the index number. If you want to, you can write the number 2 in both places. In order to simplify this radical, you must have the same index and power to cancel out the radical. So you're left with just the base of 3. Now some of you probably memorized the square root of 9 is 3. Here's the next one. You may have memorized the square root of 16 is 4. If you don't, rewrite that base of 16 as 4 squared. Remember, this is an index of 2. The square root of 4 squared is just its base, and the base is 4. A couple more quick examples. The cubed root of 8 you may have memorized. If you don't, rewrite 8. Now 2 to the third. Because my index is a 3, I must have a 3 out in front. Cubed root of 2 cubed is 2. Because my index and my power are both 3. Last example on the slide, cubed root of 27. 27 can be rewritten as 3 cubed. And then I have a 3 out in front. Since my index and my power match up, I'm left with just the base. So 3 is my answer there. Now we're going into multiplying two radicals together. The rule is you can multiply two radicals together if they have the same index. So I have a square root of 8 times the square root of 2. They both have an index of 2. So I can combine them into 1. So 8 times 2. Now I simplify that radical. I can break down 8 as 2 times 2 times 2, and then I still have this extra 2 here. Now, if If you want to combine them all together into 2 to the 4th or 2 squared, the index is a 2. So when you have pairs, these are going to pop out. 2 times 2 is 4. Question F. Cubed root of 5 cubed. The index and the power match up. So you're left with just the base of 5. Question G is a radical, and inside that radical has a fraction. The rule is you can separate that fraction into 2 separate radicals, the square root of 144, the square root of 25. Now some of you might have memorized the square root of 144 is 12, and the square root of 25 is 5. If you didn't, rewrite this as 12 squared and 5 squared. Now both have that index of 2. The square root of 12 squared is 12. The square root of 5 squared is 5. So you're left with 12/5. Question H. The square root of 18. You can do prime factorization. Break down that 18 into 9 times 2. Some of you know that the square root of 9 is 3. If you don't, break down 9 into 3 squared. What pops out is anything that's raised to the second power. Remember, my index is a 2. So this is going to pop out as 3. I cannot remove that square root of 2 because it's not raised to the second power. So that's going to stay underneath. Question I, the cubed root of 24. We want to break that down, that 24, into prime factorization. So you may want to try something like 8 and 3. 8 times 3 is 24. Then you can take the cubed root of 8, which is 2, or break down 8 as 2 cubed. Now, since our index is 3, we're looking for anything raised to the third power, which is this 2. So the 2 gets to pop out, but my 3 has to stay underneath because it's not raised to the third power. So I have left 2 cubed roots of 3. Question L, the square root of 75x cubed. We want to break down 75. It's an index of 2, so you're looking for things that are raised to the third power. So I can change this 75 to 3 times 25, and then x squared and x, where we can break down that x cubed into x squared and x. Since my index is 2, I'm looking for pieces that are raised to the second power. So I can break down 25 as 5 squared, and then x squared and x stay up as they are. And now the things that come out are things that are raised to the second power. So this piece and this piece pop out. The square root of 5 squared is 5. The square root of x squared is x. And now the 3 and the x will stay underneath. Question N, we want to break down 128. 128 can be rewritten as 2 times 64. And then x, and then I'm going to break down y into y cubed and y to the 1. Notice my index is now a 3, so I'm looking for things that are raised to the third power. I need to change that 64 so that it is raised to the third power. So take a moment on your own and try some numbers raised to the third power. Maybe 2 raised to the third, that's 8. 3 raised to the third, that's 27. 4 raised to the third is 64. So if you're not sure, just try a few numbers with your calculator if you don't have those perfects memorized quite yet. So 2, and then we change that 64 to 4 cubed, and then x, y cubed, and y to the 1 still stay as it is. Now my index is 3, so anything that's raised to the third power can come out in front. So cubed root of 4 cubed is 4. Cubed root of y cubed is y. And what I have left is the 2, the x, and the y underneath. So that's cubed root of 2xy. Question O, now we're looking for things that are raised to the third power. So you may want to break down 108, and just start with the number 2. Say, can 2 divide into 108? So take your calculator and try it. 108 divided by 2 is 54. And then I'm going to break down x cubed into x cubed and x to the 1, and then y cubed, y cubed. Now we have some further breaking down to do with that 54. Maybe just try 54 again and divide it by 2, and we get 27. So we get 2, 27, and then x cubed, x to the 1, y cubed, y cubed. Now we're looking for that last 27 to be rewritten as 3 cubed. Hopefully you have that memorized now. And then everything else stays as it is. My index is cubed. So this piece will pop out, this piece, this one, and that one. So what's out in front is a 3, an x, a y, and what I have left are the pieces that are not raised to the third power, a 2, and an x. When you get better at these, you can do some faster movement. I'm just teaching this for the first time. Now, last step is to multiply back together everything that needs to be so that y and y becomes y squared. And the 2 and the 2 become 4.